backtrack just a little bit. Just for sixth period, because I'm not going to be here. And those who are here can hear it again. So just sit quietly and patiently just for a second. What we did was found all the factors of 27, and we called them the Q's. And to get 27, it's 1 times 27 or 9 times 3. So all the factors of 27 are plus or minus 1, plus or minus 3, plus or minus 9, or plus or minus 27. And then all the Q's, I'm sorry, those are the Q's, these are the P's, all the numbers, all the factors of that number there, which is a 1. And the nice thing is the only factors of 1 are 1. And so it's a plus or minus 1. And so now we write all of these factors over top of all of these factors. And then we didn't show them as a fraction, but we could have put all these over 1. Those are all our possible rational roots. And as I said, and I'm repeating for the video, for sixth period, what I'm saying now is, if there's a rational root, it must come from this list of numbers. Okay? If there's a rational root, it must come from that list of numbers. Okay? Now, we then took this equation and graphed it. And so we put in our calculator, we graphed that equation, and we got that line. And it looks, I can't really point to it, but it looks right here that the graph is crossing the x-axis at 3. So we're going to go back to here now, and we're going to test it. We're going to see, is 3 a root of this equation? We're going to use synthetic division. The 1 came from here, the negative 9 from here, the 27 from here, and the negative 27 from there. And now, join in with me again now, the rest of you. Remember how we do synthetic division. 3 times 1 is 3. And then we add. Negative 9 and 3 is negative 6. Then we multiply 3 times negative 6, get negative 18. And then we add. Positive 9. 3 times 9 is 27. We add, we get 0. And if you remember back in the day when we first did this, we said if the remainder is 0, that means this is one of my roots. If the remainder is 0, that makes 3 a root. So one of my zeros, or roots, is 3. Okay? Now if we take what's left over and we put variables back to it, this is 1x squared minus 6x plus 9. We're just starting with the constant, throwing an x in here, and throwing the x squared in there. And so we get this equation. Now it's possible this factors again. Okay? It's possible it factors again. But it's also possible it doesn't factor again. And so we can use quadratic formula if we want, from this point right here. I'm looking at that, and it's showing the factors. But some of you don't recognize how to factor, so let's use quadratic formula. Remember, opposite of b, plus or minus, square root of b squared minus 4ac all over 2a. And so b is what? Negative 6. So the opposite of that is 6, plus or minus. And then the square root of, what's negative 6 squared? 36. I asked that question because some of you will plug negative 6 into your calculator, not use parentheses, and your calculator will tell you the answer is negative 36. And it's not. Okay? When you square whatever that number is, you have to get a positive. Minus 4 times a, which is 1, times c, which is 9. Over 2a, when a is 1. so we get 6 plus or minus. What is 9 times 4? And 36 minus 36 is, and so what is 6 minus 0? 6 minus 0 over 2, and what is 6 plus 0 over 2? I'm writing it this way. I know all of you are sitting there thinking, why would you write that? I'm writing it this way because I want you to realize there's two answers there. Okay? What is 6 minus 0?
6.
Divide 2 is 3. What is 6 plus 0? Divide 2 is 3. So what are my roots? 3, 3, and 3, right? I have a multiplicity here of 3, don't I? I have multiple roots. 3 occurred 3 times. Okay? That's not necessarily a great example, but it's certainly an odd situation that doesn't occur very often. And so that gives you an opportunity to see what to do with that kind of an answer. All right? So all the zeros here are 3s. All of them. Okay? What's that? What should you should label this finding the zeros of a polynomial function. We're finding the zeros of a polynomial function. I want to do another example that's not going to work out quite like that. We'll pause this while I select one. So we want to find the zeros of this one also. And so remember, what did we do first last time? What was the first thing we did?
Q over P.
Okay? And so these are our Q's. Darn it. My P's are only ones again. I should have selected a different one. What are my Q's? Plus or minus 1. Plus or minus 2. Plus or minus 3. All the numbers that go into 12 evenly. What else? 4, 6, and 12. So those are all the factors. So all my Q's over P's. In this case, again, we're lucky because there's only one P. It's a 1. If that was a 2 here, then I'd have plus or minus 1 and plus or minus 2, and I'd have to put all of those over each of these. But that's not the case. It's just a 1 here. And so I end up with that same list of numbers that's over there is over here. Okay, now, what was the next step I did? I found all the possible rational roots. What do I do next?
Graph the function.
I graph it. So I'm going to go back here. I'm going to go tab and up, and I'm going to replace this equation. I don't want 2 graphs on there. That might get confusing. Can someone tell me what I had there? What's the equation?
Minus 10x minus 12.
Louder, please.
Minus 10x.
X cubed minus
10x.
10x. Then what?
Minus 12.
12. So there's my graph. And I see this time it crosses the x-axis and gives me how many roots? 3 real roots, right? 3 real roots. 3 different real roots this time. And so this one right here, what happens? What's that one look like it is?
Negative 2.
-2, and then something between -1, -2, and over here I have something between 3 and 4, right? And so if I go back to this, Are any of these close to any of the ones we just got?
Negative 2.
-2. So if we try -2, take the coefficients. Someone tell me what to write here. What's my coefficients? 1, 0. Nice job. Why is there a 0 there? Because the x squared term is not there, and so we have to put it in. And then what? -10 and -12. Nice job. Drop that first number down. -2 times 1 is -2. Add. -2 times -2 is +4. If I add, and -2 times -6 is +12. And if I add, I get 0. So my remainder is 0, making this one of my zeros. That's one of them. Okay? What equation do I get left from all of this? X squared minus 2x minus 6. Now this time it doesn't factor. The last one would have, but this one doesn't. So what can I do now? Quadratic formula. That's why I showed it to you last time. The opposite of -2 is 2. What's the square root of, I'm sorry, what is -2 squared? 4. This number is b, right? -2 squared is 4 minus 4 times 1 times -6 all over 2 times a, which is 1. And so I get 2 plus or minus, what's a -4 times 1 times a -6? It's a positive 24, isn't it? And so I get 4 plus 24 is 28. Now, some of you, remember we told you before when we dealt with these, some of you can stop there. And so your other answers are 2 plus or minus square root 28 over 2. Others are going to realize 28 is really 4 times 7. And what's square root of 4?
2.
So I get 2 plus or minus 2 square roots of 7 over 2. And what is in every term? A 2. And so I can cancel that 2 out and take whatever's left. 2 divided 2 is 1. And square root of 7 over 1. Do I have to show the over 1? No. So the best answer, the one you'll find on the answer key, was -2, right? Not 2. And then 1 plus or minus square root of 7. That's how you'll see the roots or the zeros. Okay? There's 3 of them there. How many of them were rational? Yeah, it was -2. How many of these are rational? 1. How many are irrational? 2. How many imaginary? None. Okay, good. That's the concept we worked on the last 3 days on the project. How many zeros are there? Are they rational, irrational, imaginary? Okay? And so when you look at your equation, you see the degree that tells you how many zeros there are. If there's an odd number of them, that means there has to be an odd number of rational roots. That's the problem I had with that example I started yesterday. In both classes, I chose a different example each time, and in both of them, there's something wrong in that setting, and I have not determined what it is yet. But none of our answers were rational, and that's not possible, because it was a third degree equation. And so there needs to be one rational root, at least. They could all 3 be rational, but there at least has to be one rational root. Okay? And I tried them again last night and this morning using a different method. I still didn't get it to work out. Okay? So something in there, either I or the calculator or something is wrong, and I'm not sure what it is. But the ones you're working on today, you're not gonna have that issue with. Your assignment today, will you remind me what I said?
It is page 337, 9 through 16.
It's 337, 9 through 16, and
21 through 24.
okay? There aren't that many. There's only 3 solutions. Some of them will be very easy once you graph them to see. You still need to test them because you need to get this. You still need to get this so you can write this equation and solve for the rest of them. Okay? On this earlier example, I said it factors. Some of you might have looked at this and said this factors. Signs have to be the same as this, so they're both minus. I need an x and an x. What are the factors of 9 that add up to 6? 3 and 3. And so if you notice that factor, then factor it. Okay? If you notice this problem, factors, then factor it. Okay? You don't have to do all that other work. I taught you how to factor to save you time on situations like these. X to the 4th, remember we put a's in place of x squared? So if you've done a few of them, you might just go straight to x squared and x squared. Signs are different. Factors of 8, subtract to give me 6. Oh, I messed up. Let's make that signs the same. I just created one that didn't work. So the signs are same. Now factors of 8 to add up to 6. 4 and 2. And then you can take each of these and solve them. In this case, we get real on all of them. 2 rational and 2 irrational. Okay? Remember, add 4. Square root both sides. Plus or minus 2. Add 2. Square root both sides. Plus or minus square root of 2. 2 rational ones, 2 irrational ones. I went quick. I'm going to post it. You can look at it again. You have all class period to work. Mrs. McDonald and I will help you get going. Okay? And now at least 6th period, because I'm going to be gone, we'll have something to look at.